Good day everyone, I'm Eugene De La Cruz and I will be discussing how to analyze simultaneous games. So let's consider this problem. Consider a game in which there is a prize worth $30. There are two contestants, A and B. Each can buy a ticket worth $15 or $30, or not buy a ticket at all. They make these choices simultaneously and independently. Once the ticket purchase decisions have been made, the prize is awarded. If no one bought a ticket, the prize is not awarded. Otherwise, the ticket is awarded to the buyer of the higher cost ticket if there is only one such player, or split equally between the players if there is a tie among the highest cost ticket buyers. So what we are looking for in this problem are first, write the normal form of the game. Second, are there any dominant strategies in this game? And lastly, are there Nash equilibria? If so, determine how many and state which strategies. So let's first focus on writing the normal form of the game. So based on the problem, there are two players, player A and B, and each player can take three actions, which is either to buy a $15 ticket, a $30 ticket, or not buy a ticket at all. So based on that, we can form this table. So as stated earlier, each player can buy a $0 ticket, $15 ticket, or $30 ticket. And the same goes with player B. So now let's consider the payoff of each action. So if both players buy a $0 ticket or did not buy a ticket, then none of them will win the prize. So the payoff is 0, 0. If one player does not buy a ticket, but the other player buys a $15 ticket, then the one who bought the $15 ticket will win the $30 prize. So since the prize is $30 and the ticket costed $15, then the net payoff will be $15. So the one who bought the $15 ticket will gain $15, while the other player who did not buy a ticket will not get anything. Next, what if one player did not buy a ticket, but the other player bought a $30 ticket? So obviously, the one who did not buy a ticket will not get anything, while the one who bought the $30 ticket will win the $30 prize. However, since the price is $30 and the ticket costed $30, then the net payoff will be 0. Next, what if both players bought $15 tickets? So since the cost of the ticket is the same with both players, then they will have to split the price equally. So since the price is $30, then each player will get $15. However, since the cost of the ticket was $15, then the net payoff for both players is both 0. Next, what if one player bought $15 while the other player bought $30 ticket? Then the one who bought the $30 ticket will win the prize of $30. So the one who bought $30 ticket will win $30, so the net payoff for that player is 0. So what about the player who bought the $15 ticket? So the one who bought that ticket will not win anything, so they lost $15 or negative 15. And lastly, what if both players buy a $30 ticket? So in that case, they will have to split the price of $30. So each player will gain $15. However, they both spent $30 on their tickets. So the net payoff for each player are negative 15. So this is now the normal form of the game. So next, are there any dominant strategies in this game? So we define a dominant strategy as any strategy with payoffs no better than those of at least one other strategy, regardless of the choice of other players. So it is basically the strategy that beats any other strategy, regardless of what the other player chooses. So let's look at player A first. So let's see if player A $0 is a dominant strategy. So player A $0, if we compare to the other strategies, the first one is already being dominated by the $15 strategy. So that means that the $0 strategy is not a dominant strategy. Next, let's consider the $15 strategy. The first one, it is a dominant strategy since 15 is greater than 0 and, of course, 0. 0 is equal to 0 and 0. And the negative 15, it is being dominated by 0. So therefore, the $15 strategy is not a dominant strategy either. Lastly, the $30 strategy. So the first one is already being dominated by the $15 strategy. So that means that the $30 strategy is not a dominant strategy. Therefore, player A does not have a dominant strategy. But what about player B? So let's take a look at the $0 strategy of player B. So the $0 strategy is also being dominated by the $15 strategy, similar to player A. So the $0 strategy is not a dominant strategy. Next, the $15 strategy. The first one is a dominant strategy. The second one is equal to the other strategies. However, the last one is being dominated by the $0 strategy. Therefore, the $15 strategy is not a dominant strategy. Lastly, the $30 strategy. So it is being dominated by the $15 strategy, therefore, this is also not a dominant strategy. Therefore, player B does not have a dominant strategy. So that means that this game does not have any dominant strategy since both players does not have a strategy that dominates any other strategies. And the next question here is, are there Nash equilibria? If so, determine how many and state which strategies. So, a Nash equilibria is a list of strategies with one strategy per player such that each strategy on the list is the best response to the other strategies on the list. So let's take a look first at player A. So if we assume that player B chooses the $0 strategy, what is the best strategy for player A? So if we look at this, the best strategy here is the $15 strategy. Since 0, 15, 0, the best one is 15. But what about if player B chooses the $15 strategy? In that case, all of player A's strategies will yield a 0 payoff. So let's box all of it since they're all the same. So lastly, what about if player B chooses the $30 strategy? So in this case, player A either gets a 0, negative 15, or negative 15. So obviously the best one here is the 0. So now let's consider player B's strategies. So what if player A chooses the $0 strategy? So in that case, we're comparing 0, 15, and 0. So the best one here is the $15 strategy. Next, if player A chooses the $15 strategy, then player B have all zeros. So they are all the same. So we box all of them. And lastly, if player A chooses the $30 strategy, then player B has 0, negative 15, or negative 15. So the best one among all of these is 0. So now that we have considered all of the strategies for both players, we now look at which ones are the Nash equilibriums. So the ones with the boxes in both players are the Nash equilibriums. So in this case, it is the 0, 15, the 15, 0, and the 0, 0. So these strategies are the $15, $0, the $15, $15, and the $0, $15. So this is assuming that player A goes first and player B goes first. So these three are the Nash equilibriums. And that concludes this problem.